Hey everybody, this is Larry. This is me going with Q4 of the weekly contest for 21 total characters in string after transformations 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I think first of all I want to say that this one is a very hard problem if you haven't seen it before. I know that a lot of the top people solved it very quickly, but honestly, if you haven't seen this problem before, or if you don't know the technique, it's just impossibly hard to come up with it. Or if you already did, then you're probably not watching this video anyway. But the technique idea is very tricky, right? So, or like it's not that to come up with, but it makes this problem a little bit weak in that sense, because if you don't know it, then it just doesn't, like, I don't know if there's any way for you to come up with it. And in that sense, it's also why it doesn't come up that much on Code Forces, because it's such a thing that enough top people know. Because all you have to do is solve this like once or twice to really get it, but enough people know it. But it's not challenging, but it's just such a weird barrier. And I don't know, maybe on harder Code Forces problems I am wrong, but that's really the reason why this is a dubious problem. But we'll go with the math. First of all, I want to say that Q2, is it Q2? I think it's Q2. Q2 is the prereq for this problem, so definitely go watch that video if you haven't already, and really understand that one first, because I'm not going to repeat it. But for this one, I assume that you have a good knowledge of or understanding of Q2. So the other thing is that, of course, there are two differences between Q2 and this problem. Actually, let me bring this back down for a second. One is that, well, T is ridiculously big, 10 to the 9, so you can really do a step-by-step transformation. And then the second thing is that you instead of whatever function they do, you're given like basically a range of characters that it turns into, right? So so then now, let me bring back up the thingy. Without loss of generality, and kind of just make it a little bit simpler, let's say we have 4 characters, right? A, B, C, and D. So then, and maybe we say that A turns into B, B turns into C and D, C turns into, I don't know, D, A, and B, and then D turns into A, say, right? Something like that. It just kind of randomly pulled it out. Now, what does that mean, right? Well, what you need to know for this problem is linear algebra. And it's a little bit tricky kind of thing, right? But that's really how like I said, it's, I wouldn't call it trivia, but it is something that just, for this problem you need to know. Whether you need to know this for an interview, I would not consider it, but for this problem anyway. And what it means is that basically you can kind of look at this thing, right? You go, okay, we have this setup. So then now f of a of 1 is equal to, well, what does it equal to? Well, a is equal to f of c of 0 plus f of d of 0, right? Because that's after the and f of I don't know, I comma k is equal to I is the character, right? And k is the iteration of t, right, from 0 to t, the number of iteration. So then f of a sub 1 is equal to this thing, right? You can even say that this is the new f, but maybe something like that. F of b is similarly written, right? F of b sub 1 is equal to let's see, f of a sub 0 plus f of f of c of 0, right? And then f of c of 1 is equal to, basically what I'm doing is that looking on the right side where it appears, and it's on b, so then it's just f of b sub 0. And f of d sub 1 is equal to, in this side, it's just this one actually. Oh, and here. So then f of b sub 0, f of c plus c 0, right? So okay, so you have this thing, right? And then now the idea is that you apply it many times, right? So this is kind of a transformation, right? I know that I wrote it with the index, but you can kind of imagine that rewriting it as you can imagine rewriting as let me use another color. So like you can imagine writing it as I, right, or here, and then I plus 1 here, right? And that's really the thing, right? Is that you keep on going in this way in the algebra. And without really going into the mechanics of things, because it is way beyond the scope of anything, it turns out that yeah, if you multiply two transformation matrix, then it allows you to do 2 operations at the same time. Well, it allows you to get the composition of the operations, to be more precise. The same time is a little weird phrasing, but yeah. And what I mean by that is that, well, this gives you one operation. So in order for you to get, you know, if you want to say t is equal to simulation, then now you just do this thing twice, right? And it turns out that in linear algebra and matrix math, it just means that you multiply the matrix. And you can kind of, you know, the way that I wrote this out, you can kind of figure out a little bit as well. Let me actually erase this part. So is that the matrix would look something like this. Let me change the color. Right, the matrix would look like, okay, well, the new A's are going to be 0, 0. It has contribution of something like this, right? Yeah, and basically this is what I would say. This is T, where is the transformation matrix, and then now every time you multiply it by this matrix, you actually get one iteration on this T. Maybe T is confusing. Let's say T of a transformation. I don't know if that's good, but yeah. So basically now, another way to think about solving this, and I actually did this live during the virtual contest, is that after coming up with this matrix, you actually multiply this T number of times. Of course, that is still too slow because T could be 10 to the 9. Because then now, what you have, and let me erase this part now, is that basically what we want is we want TR times TR times TR dot dot dot, and then you have T times, right? And of course, this is a thing that you can notice is that this is just equal to TR to the power of T, right? And of course, in this case, right, now you can do fast exponentiation, right? By, you know, divide and conquer, because hopefully this part is not, I'm going a little bit fast, and but the math I feel like you can prove at home. The linear algebra part is a little bit tricky to prove, but there will be more videos on it, so definitely check those out. But that's basically the idea. But the fast exponentiation is just that TR, or not even TR, or just, it works for even non-matrix, is that if you have A to the M is just equal to and if you're trying to calculate A to the M, it's just going to be A times a, or maybe a squared times m over 2, right? And then you do this as divide and conquer. Of course, if you have odd, you can figure out the cases. So that's really the idea behind this problem. Like I said, it's very specific, so like I don't know how I feel about it, and that's why I'm kind of like just reading you the answer. I know that I talk about it a little bit more, but I knew how to solve this as soon as I actually even saw Q2. I saw it, but I didn't think it was necessary until Q4. But yeah, it's just something that if you know it, you know it. If you don't, But I actually did write this out. I think in Python there are libraries to help you with this, but I just wrote it out. Yeah, and the first part is just to keep track. Keeping in mind that I convert this to 1 to the. I think I missed a little bit, but again, that's part of linear algebra. But yeah, so now we convert it. This is the frequency table. I make this a 1 by n instead of I think on the Q2 I made it a one-dimensional 26 element thing, but here I just made it 1 by 26, right, as a matrix. And here we have the transformation matrix, and depending on the nums, which is the input that we get for each character, the range that we get, so that we can set up the formula, we set up the transformation matrix to be 1 because that's the contribution from the next one. Technically, I think this is the transpose of this, but I kind of wrote it this way, so my apologies if you really want to be really precise. I think technically, if you really want to be precise, and luckily for me, for this one, it doesn't matter because it's a square matrix, and it's just a transpose, so it doesn't matter that much. But you actually should, if you want to be more precise, write it this way, I believe. If I'm wrong, let me know in the comments, because this stuff is a little bit tricky sometimes. But in any case, you need it to be a square matrix to be to multiply by itself anyway, right? So maybe it never matters, and I just always get it confused. I don't know, but yeah. In this case, and I would also say that I did. If you watched the live portion of it, I was a little bit tempted to Google because I knew how to do it, or even just look at my old code. But I actually try to do everything from memory, so some of it is a little bit sketch. Hope that's okay, but yeah, everything's from memory, so there's nothing. I want to say there's nothing too crazy, but it is what it is. It is a little bit crazy, right? So yeah, so we have this multiply function, right? This is just regular matrix multiplication. And this is setting up the transformation matrix. And yeah, and if you watch, I guess I deleted it, or I replaced it, but if you actually watch me solve it live, which is in the later version, or you can fast forward to it or whatever, I actually do something like, when you go to t, we multiply the transformation matrix like whatever times, right? So I did it this way just to check my answer. So I think this is off by 1 technically, but yeah, I just kind of did it this way, just to kind of check that I'm not off by 1, so I could get it correct. And you could, but after that, I just kind of you can see that I take tr to the t power, and this is regular exponential things, right? As I said, if it's even, then you multiply m squared to the power of half. Otherwise, you do the same thing, but you have an extra m left over, so you have to multiply the m here. Keeping in mind that the mods are already on the individual element-wise thing in the matrix. I don't even know what I'm talking about anymore. So that's pretty much it. I do this one more thing where yeah, that's just a transformation matrix. So this assumes that you start with an identity matrix, which means 1 of each character. But you can actually set it up by just multiplying it by the frequency, which is the 1 by 26 matrix that we have in the beginning, which is why we set it up this way. Yeah, and that's pretty much it. So you multiply it, it'll give you a 1 by 26 matrix, so that's why I took the first dimension of it, and then I just sum it and then mod it again. So that's pretty much it. What is the complexity here, right? Let me make this slightly smaller. Right. Yeah. So this is going to be the transformation matrix is just going to be A times. I guess this can be at most A because you can only go up to 26, I think, or 25 maybe. I don't know. Yeah, just 25. So this is actually A square, or A being alpha, right? The size of the alphabet. This is over alpha. This is alpha square. Matrix multiplication. It's just going to be based on a dimension. Of course, this is going to be 26. So this is at most 26 cube or alpha cube. The reason why this is a little bit funky looking is because we wanted to do a 1 by 26 matrix times a 26 by 26 matrix. So that's why it's a little bit different. But in the worst case, this is going to be alpha cube, right? Yeah. And here, yeah. And this one, P, where P can go up to 2 billion, is it? Or 1 billion, sorry. 1 billion, but because of, divide and conquer, we always divide it by 2 every time. So that means that this does at most dirty operations, right? So log of P is what, and this is regular fast exponentiation stuff, right? So yeah. So, and so you do at least 30 operations on this thing, each with maybe 2 multiplication at most, if it's all odd, say. And in that case, it's going to be O. So here, it's going to be O of log P. Technically it's linear in P, but I guess this is a little bit more clear for now. And P is the power, so technically it's T, which is the input, times alpha cube, right? That's pretty much it for time. There's one more multiplication, but that's going to be dominated by this alpha cube anyway, so yeah. And that's pretty much it. Like I said, a lot of this, I know that I didn't really go over how the inner workings of the matrix stuff works. I think I went over the setup a little bit, but in setting up the set of linear equations, but this is this is linear algebra stuff, so yeah, I'm not going to be able to explain this in a couple of minutes. So yeah. That's all I have for this one. Let me know what you think. It's it's a problem. I don't know what to say. I don't know if it, it's a little bit so specific that it's not. I don't even know if I consider this hard. Other than that, it's just more specific, right? Like it's hard in the worst ways, and specific in the worst ways, because I feel like if you know it, you get it so quickly, and people did, right? There's nothing else to solve if you know it. And if you don't know it, then it's impossible to solve, which is also silly, right? So yeah, so you can't grind it out, really, and without reproving a lot of linear algebra stuff, right? So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good. Oh no, wait. You could watch me solve it live in the contest next. You'll see me kind of break it down a little bit more, but that's basically it. Thanks for watching. And you can watch me solve it live now. Quite yet. But I think I know how to do Q4, and assuming it is what yeah, 10 to the 9. What is this other stuff? Oh, num. So this is the same thing, except for, because okay, let's actually read this real quick. Replace S sub I as the nick. Oh, Jesus. Okay, but it's the same idea though, so I think I should be able to get this. This is just what do I have here? What's num sub I? Oh, with the next. Okay, I see. All right. Mod. So it's not quite the same thing, right? But it's just a transformation matrix thing. Okay, so in theory, this would be right. I just want to, right now I just want the brute force one, just to make sure that I am not being silly. So then now, for C in range of 26, then now we want, so then NF of C plus I mod 26, right? C, something like this, where I is, for I in range of num sub C, right, it's the next one, so it'll be 1 plus this thing, and then we have to make sure that we mod. Okay. How did this happen? Do I know how to code? 7 and 8, okay. So this is going to time out because T is in pretty big. So we have to just set it up, right? So, okay. So how do I set it up? Yeah, I mean, okay. So then A is equal to, you have to set it up in reverse, Larry, because new A. Okay, so yeah, you have to figure out how to set it up in reverse. So that means that the contribution of, what is the transformation matrix? Is it just the inverse of this, or not inverse, but the flip transpose? I think it's just transpose then, right? Is that true? Because A contributes to B. Oh, no, this is right. No, it's not transpose. You're right. So then now, okay. So then maybe something like, okay, let's just do this, right? And then you replace an A with the thing. So yeah, so then now out of C plus I mod 26 is equal to 1, right? Okay. Yeah. Okay, so then now we just have to, I don't know how do I do matrix multiplication exactly? It's, I could write matrix mode. I feel like there's a library in Python, but for now I'm just going to write it. Yeah, whatever, we just assume it's 26 by 26. We know it's for this one, right? So then now, I need to change this actually. Let's say A for you. Having too many 26 is not great. Oops. I think this is right. I could be wrong. Right, so then now here we have, we want to multiply mat with, oh no, this is T for transformation, right? And I'm just gonna make it, yeah, okay, fine. something like this. So then I hope I get the directions right. I think this isn't quite right actually. I think this should be. Something like this, but okay. I think this is fine. Okay, and then you're supposed to multiply it in a. Okay, fine. Let's just do this real quick. Oh, that's not quite right, is it? Oh no. At the end, after 2 transformations, you have. No, you're supposed to multiply by the initial. You're supposed to multiply by f, I think. Okay, fine. This is a little bit too lazy to think. So there'll be. Something like that. It's 1 by 26. Yeah, I think this is right. Int object not. Oh, this isn't quite right. So k is going to be linked with. Also, yeah, okay. It's too hard to remember all this stuff. Do I pass it? Oh. Let's just ignore that for now. Okay, that looks good. Or looks like it does something. What? Oh, I multiplied the wrong thing, that's why. Oh, because it's not a 2-dimensional thing. It should be 1 by. Oh, I did it the other way. Whoops. Yeah, okay, fine. Oh, I confused things again. In Python matrices are weird, honestly. Okay, so that means that there's 5 and that means that I'm very wrong. 1, 2, 3, 4. Maybe I. So this is 7. Don't. Maybe I just did the math. Oh yeah. Oh, because I started by 1. Okay, I was wondering why I'm off because okay. So then this is right, I think. So this is gonna be sum of this. Used to be so much faster in this actually. Oh, because it is a matrix still. It's a 1 by whatever matrix. Okay, fine. I'm being dumb. Okay, okay, yeah. So then it's just this 0, right? That works, right? Nope. Wait. Oh, no, this is right. Okay, so this is basically the idea. Except for it's too slow. But now we do, yeah. Whatchamacallit? Exponentiation, right? So basically, we don't need identity matrix actually. We just actually want to t minus 1. Right? We always make at least one transformation. Okay. So then now that is if p minus 2 is 0, 0, then we just want to multiply. I have to fix this, but that's easy actually. This may be a lot of operations, but whatever. We time out. I blame it on Leetcode. Okay, so we do m by m. Okay, if p is equal to 1, we return m. Otherwise, if it's odd, then it is. Yeah, I mean it's the same thing, but we also multiply this by m. And this square matrix is it is commutative, I hope. Oh, how did I? Oh, I left this in for some reason. Do I not have a good enough base case? Oh, because p could be 0. So if p is 0, well, should return the identity matrix, but am I right on this one? Did I just messed up? Maybe I'm off by 1. That doesn't make sense, right? This doesn't feel right. This is off by 1. We do one transformation, so let's see. I think this is more clear. I don't think it could be 0, but it makes all the math so confusing. Okay, so this should be good. Let's try a big case, I think. Oh, I was gonna say we should try this on Q2, but I guess not. I mean you can, but then you have to adapt it a little bit. Yeah, let's do it. How much time I left? Half an hour? An hour. We can. Is it worth 5 minutes? Okay, let's just YOLO. Whatever. We don't. Fine, let's YOLO. Run it again. Double check. I know how to do all the mod. Okay. Okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you're thinking about this contest, this video, the explanation, everything in between. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye-bye.